Slide 1. Welcome to Networking and Health Information Exchange Supporting Standards for EHR Application. This is Lecture C. This component, Networking and Health Information Exchange, addresses what is required to accomplish networking across and among disparate organizations who have heterogeneous systems. Unit 7 covers Supporting Standards for EHR Application and consists of 4 lectures. Over these 4 lectures, we will talk about the additional standards that are available to support interoperability across different applications that relate to or are interactive with the electronic health record. In Lecture C, we will discuss additional clinical decision support standards, including the info button and disease management. Slide 2. The objectives for this unit, Supporting Standards for EHR Application, are to understand the Clinical Decision Support Standard ARDEN syntax, understand standards for clinical guidelines, understand Object-Oriented Expression Language for Clinical Decision Support, JELO, understand the Clinical Decision Support Standard info button, understand disease management, and understand other clinical decision support applications. Slide 3. Additional objectives for this unit, Supporting Standards for EHR Application, are to understand other standards that help to support networking and reporting requirements, as well as functionality to optimize the connectivity among heterogeneous systems deployed within a single enterprise. Understand single sign-on standards and the HL7 Clinical Context Object Workgroup (CCOW) standard. Understand regulatory standards and understand issues relating to person identifiers, master patient indices, and record locator services. Slide 4. On average, physicians will have 2 questions for every 3 patients seen. These questions deal with treatment for specific problems related to a diagnosis, related to a medication, or other. About 50% of these questions go unanswered. The info button is designed to contribute to the solution of this problem. The info button is a key standard originally developed at Columbia University by Dr. Jim Simoneau and others, and now being developed as an HL7 standard. The info button has been very quickly accepted and implemented by the vendor community. The beauty of the info button is that it can be tailored to the class of the user. One set of information for the professional, another for the layperson. The info button provides context-sensitive links to information that can be seamlessly built into the clinical information system. It uses a service-oriented architecture (SOA) framework, sending queries to the CDSS using data from the EHR. The info button functions by generating and sending queries to the CDSS using data from EHRs. The CIS places an info button next to a data element such as a diagnosis, lab result, which may be abnormal, or a drug. When clicked, the info button causes a query based on the context of the interaction, the patient, the data, the activity, and the user. This context-sensitive interaction between data and knowledge is an extremely powerful tool. Slide 5. The software that supports the info button is encapsulated as an SOA component which provides the decision support service, providing an application-independent service. The context data is fed to the component in a prescribed fashion using an XML syntax. The info button software responds with a displayable message. The application passes parameters to the info button manager, which generates an HTML document with a set of natural language questions that are hyperlinks to clinical information resources. The info button software is independent of the CIS application. Either can be changed or updated without impacting the other. Slide 6. This slide shows only a few of the information sources available. Examples are Micromedics, MD Consult, UpToDate, and Medline Plus. Unfortunately, the access method for each of these resources is different. please see the specific access methods listed on the screen. Info button, however, is aware of the access to each of these resources and properly configures the query. Slide 7. The implementations are XML or URL-based for the HL7 info button. Standard languages supported include RxNorm, LOINC, SNOMED-CT, and MESH. The URL can be automatically derived from the XML message. Free text is an option. Slide 8. The web address www.infobutton.org is a home page for info buttons. This web page provides links to work on info buttons at NIH Laboratory for Informatics Development, National Library of Medicine, University of Utah Department of Biomedical Informatics, Columbia University Department of Biomedical Informatics, with further links to the work at HL7 on info buttons. In the example above, the medication abciximab preparation has an info button that, when clicked, brings a pop-up screen that shows prescribed data about this drug for this patient. Slide 9. The slide shows a screen display of an info button application from Columbia University. In this illustrated example, the user is interested in information about a drug, captopril tablet, 12.5 milligram strength. The info button manager creates an HTML query that creates a hyperlink to LexiPals, which delivers a web service display. Based on characteristics of the user, the response is in Spanish and comes from the Internet. The info button manager also displays frequently asked questions, so the user can expand the user query with just an additional click of the button. Other links are provided. Slide 10. This slide includes another info button example. In this case, the response is tailored for a patient and provides additional services and links with the patient's EHR. This example might be part of a PHR application. The example addresses tobacco dependence and provides support information to encourage the patient to quit smoking. Slide 11. Much of healthcare has expanded beyond acute care to dealing with chronic disease. As patients live longer, dealing with chronic disease has not only become important but uses more resources. A RAND study in 2001 reported that Americans only received 54% of the care they required. In many cases, this poor quality is related to the failure to manage chronic disease. An important use of HIT is directed toward the management of chronic disease. Each chronic disease has data elements that need to be tracked, tests that should be performed, and the results monitored, appropriate medications, and return visits at specified intervals. The Disease Management Program manages all of this for a particular disease and the patients that have that disease. It tracks events, issues reminders for required tests, and identifies patients whose goals are not reached. For example, if the goal of a diabetes disease management was for all patients to have a hemoglobin A1C of less than 7, a list of those patients not meeting that goal could be generated. Those patients could, for example, be scheduled for a visit, a letter, perhaps urging compliance with the treatment could be sent, or some other appropriate action be taken. The Disease Management Protocol also manages workflows with report creation and other workflow processes. Slide 12. This slide illustrates a disease management system which supports DM programs for diabetes, asthma, chronic obstructive pulmonary disease, COPD, coronary heart disease, CHD, chronic heart failure, CHF, and primary heart disease. There are potentially over 100 diseases for which disease management protocols could be developed. This example includes some of the items tracked for patients in the CAD registry. Slide 13. Computer Physician Order Entry Systems, CPOE, are becoming prevalent in developed countries. Although these systems are often vastly different, all have in common the objective of appropriate testing, patient safety, higher quality of care, and reducing cost. CPOEs include decision-based algorithms to accomplish those goals. The algorithms for driving these systems are shareable, and standards are being developed to enable that process of sharing. CPOE systems need to be patient-specific, considering patient demographics, age, gender, other, site-specific, disease-specific, and event-specific. CPOE systems often include healthcare plans to influence what tests are ordered and what treatments are given. Slide 14. This slide shows typical pseudocode within a CPOE system, which provides the logic for, in this case, treatment method. The protocol relates to the administration of heparin. Heparin is started and adjusted according to the patient's weight and the last APTT. Slide 15. This slide shows a screenshot from the Vanderbilt CPOE system. In the background, you can see the patient clinical data on the left and the CDSS calculations on the right. In this case, the CPOE algorithm issues a warning because the proposed order dose for gentamicin will result in a trough level that is too high. Consequently, a potential medication error is averted thanks to the smart CPOE system. Slide 16. The following describes the process for using this order entry application. Upon the doctor stating patient is eligible for protocol, the CPOE system calculates the heparin dose and makes it easy to order tests associated with the guidelines. Links to educational materials available in the protocol. The doctor reviews relevant medications and labs, and the doctor selects actions and clicks button to activate guideline-related orders. The Vanderbilt system, WizOrder, has been used to implement Vanderbilt University Medical Center, VUMC, Care Improvement Committee's protocol for DX and treatment of patients with suspected or confirmed deep venous thrombosis or pulmonary embolism. The protocol for this advice system is based on extensive literature review and consultation with local experts. Additional web pages help doctors to subsequently adjust heparin doses as called for by this complex weight and test result-based protocol. Slide 17. This slide shows a care recommendation used by the Regenstrief system related to the giving of a flu shot. The recommendation is made only in the flu season, takes age into consideration, and looks for possible reaction based on egg allergy. If the patient is over 65 or has a diagnosis of COPD and is not allergic to eggs, then give the flu shot because the patient is in a high-risk category. The CARE system at Regenstrief has been in use for about 40 years. Slide 18. This slide shows a reminder for a colonoscopy test. It is a reminder that people between the ages of 50 and 75 should have a colonoscopy once every 10 years, or more often if the last study showed polyps. If you had a colonoscopy, please enter the data for it in the Preventive Tests Screening section. Added to the reminder is the Framingham 10-year heart risk for this patient, which is 63%. Slide 19. The Framingham Heart Study is a very famous study that dates back to 1948. The subjects return every 2 years for a detailed medical history, physical examination, and laboratory tests. A second generation of patients were recruited in 1971. This database has been significant in creating risk factors for heart disease and its many aspects. This example shows the risk factors for stroke after atrial fibrillation. Algorithms are provided by which a person can enter data and the programs will calculate their risk. As an exercise, go to http://www.framinghamheartstudy.org/risk/index.html and see your risk factors for various heart diseases. There are many similar web pages available on the Internet. Slide 20. Decision trees are popular ways of using statistics and probabilities to guide decision-making. The first step is to define the problem in concept and scope. What are the alternative decisions? An example might be to treat the patient surgically or medically for a particular problem. Another is to operate or not operate. For outcome tracking, determine the percentages for each outcome based on what is done and specifics of the patient. What are the steps leading to the alternative actions? These choices are represented by chance nodes, defined by the actual data, and decision nodes, identifying the alternatives. Determine the probability for each chance outcome. What is the probability that a patient with these symptoms might have the disease, for example? Finally, assign a value to each outcome. These values might be survival or death, for example. Slide 21. This slide shows a simple decision tree. Decision nodes are represented by a box, chance outcomes by a circle. In this case, the decision choice is to operate or not operate. The chance outcome is the patient has the disease or the patient does not have the disease. The tree shows the set of possible outcomes, each of which would have an assigned value. The tree would lead to an action that selected the highest outcome value. The choice probabilities, which are not shown, would represent the prevalence of the disease. Slide 22. This slide shows an example of why patient preference is an important factor when selecting a course of action. Only the patient can make these decisions, hopefully after being informed and educated about the possible decisions. Some people would select length of life over quality of life. Others would do the opposite. Each person probably would have a different threshold at which they would make a decision based on length of life versus quality of life. At what level of quality of life would death be a preferred alternative? Are you a risk taker or not? This tool makes it easy for a person to convey that decision to a physician. This gamble approach can also be used for simple things, like obesity. Given the probability of bad outcomes, at what point can we get patients to attempt to lose weight? So it is an educational tool as well. There are a number of these risk analysis programs available, including the one from the Framingham study previously mentioned. Here is a reference that deals with this topic that is useful. http://people.dbmi.columbia.edu/tilde/cmr7001/sdm/methods.htm. Slide 23. Evidence-based practice results from clinical trials, data mining, and expert opinions documented in the literature. Evidence-based medicine are traditional conceptualizations based on research utilization, clinical trials based, and clinical practice guidelines. It is the application of domain knowledge to patient care evidenced as a continuum. At the present time, the length of time from the discovery of new knowledge to routine bedside use is around 17 years. Current funding in such programs as the Clinical Translational Science Act, CTSA, is an attempt to speed up this process. Using newly acquired knowledge to create clinical guidelines and decision support algorithms is one way in which this gap can be closed. Application of evidence and prevention of errors, commission and omission, through diagnostic decision support, expert systems, other decision aids, decision analysis, computer-based provider order entry, and practice guidelines. Slide 24. This web page shows another source for clinical guidelines. There are many such sources available on the Internet and can be found through Google. One must, however, evaluate the quality of the work. Slide 25. The Cochrane Database of Systematic Reviews is another popular source of information that can be linked through the info button. In this case, the query is related to the use of vitamin E for Alzheimer's disease. Slide 26. Another example of a form of a decision support application, in this case, assessment of falls and injuries. Slide 27. This slide shows a risk assessment tool for cancer from MD Anderson Cancer Center. It also can be accessed through Info button and might be a part of a PHR system. Below lists other useful links with similar material. http://www.md-anderson.org/cancer-information/cancer-information/cancer-risk-factors/prevention-and-screening/cancer-risk-factors. Here is an interactive site for lung cancer risks. http://www.mskcc.org/sites/flash/lung_cancer_risk_assessment/index.html. Here is a link for colorectal cancer risk. http://www.cancer.gov/colorectal-cancer-risk/#. Slide 28. This slide asks questions about a patient's diet and calculates cancer risk. The toolkit also educates the person about cancer-preventing diets. Slide 29. This slide shows a risk assessment protocol. The results include a 10-year risk assessment and a lifetime risk assessment for developing colon cancer based on a few simple answers. Such tools are useful in influencing patient behavior. There are many such resources available on the Internet. Most are free for use. Slide 30. This concludes Lecture C of Supporting Standards for EHR Application. This lecture has presented the HL7 Info Button Standard, a feature that provides context-sensitive access to key knowledge. The value of the Info button is that it is easy to implement and use. It can be used for almost any purpose, and it provides trusted links to key knowledge resources. This lecture also illustrated several of the knowledge resources that are available on the Internet.